I've not seen one of these before, but it looks very similar to a gaming laptop I had in sort of design. But this brand is Mechrevo. What even is Mechrevo? Not heard of that one before. This web design is just appalling. This doesn't function at all. This is the Mechrevo website, and it's very broken. Nothing's formatted properly. It's all over the place. Not a lot of faith in the branding. This one doesn't turn on, whether it's just because it doesn't charge. There is no lights coming up. It's not running off the charger. The charger has voltage coming out at the moment, so it's not that. Maybe the battery's dead and it's not charging, so it can't run off the charger. So, hey, dual wielding SSDs. That's pretty cool. We do have a hard drive slot there as well, and it was populated. Battery slot. Once you've taken out about 400 screws, the bottom should come off. Cross fingers. So remove the SSDs and the Wi-Fi card, as it's half attached to the motherboard and half on the case, and it does seem to be that the bottom, or the main board, is coming off with the back of the keyboard, so it's going to stay behind when this comes off. It appears that these at the back by the screen hinge, little decorative covers come off. Just kind of separated on me after I was flexing it open. At least the other side did. Hang on, maybe they slide or something. No. So it looks like the keyboard comes off and the motherboard left behind. What's under there? Oh, it's hard to say. Okay, the motherboard is left behind in the bottom. So, but something is holding it back here. I wonder if this cover has to come off. So close. It does seem to be caught down in the screen hinge end. Make sure you unplug these 3 flexes from underneath the SSDs. And yeah, that allows that to pull through. I unclipped that along the back edge and it wouldn't let go still, but just shimmying the top like that appears to have encouraged it to pop off. Which leaves us some screws down in here. And with those 3 screws that sit underneath the case edges there, it allows this to slide off. Now I've probably got another flex there for the power button, so I just better be careful. Hang on. No, we're okay for the power button. This is a cool little switch. A bit hard to see, but it's actuators on either side of what looks like an LED right in the middle. It shines up through the button, so it's a neat little design. Remove this sheet. Can hang off the cable that's attached to it. Have a bit of a visual. No signs of liquid damage. It's all very clean. There's barely any dust on the fans, so this is actually in really good condition for what appears to be an older laptop. I'm not too sure the generation of it, but I don't think it's current. If it was, it'd be under warranty. Here's our DC in jack. So I'm curious if we have 19 volts on there when it's plugged in, or if maybe something's loading it down. 19 volts, so we don't have a short on our input, which is good. I'm going to see if there's any voltage on the power button. We should have about 3 volts or so as our normal sort of standby logic type. Okay, see how that's fluctuating. I don't know if this is the switch contact or the LED, but it sort of ramps up to, ooh, no, it's like coming up and then going off. Looks like our 3 volt and 5 volt standby rails are on the other side of the board, so I'm not too sure what I'm measuring on this side. Yeah, we'll have to flip the board out. So you got to unscrew the fans because they come out with the heat sinks, albeit just taped onto the side there. Initial glance says everything looks okay, nothing burnt, nothing wet, nothing obvious. The input MOSFETs I think look like the heat sunk. So we're going to have to take off, I think, both the heat sinks really to see what's going on. But yeah, we've got our more regulators down here as indicated by all the inductors, so one over in the corner, we can plug it in and see if any of those are giving us a standby voltage. Here's a nice boring task. Why did I push record? I'm sure you all know how to take a screw out. She's going to be well adhered with all the sticky thermal pads under there as well as being stuck to the PCB. She's well tight. We don't want to damage anything. Just give it a bit of a wiggle maybe. Be careful of and see if we can pry up on that while we're wiggling it. Oh, here we go. Sort of a little light upward pressure there, and a bit of a wiggle. There we go. Lovely dry thermal compound. It's one thing the user manual should say is repaste your CPU once every so many hours of runtime. So when it all dries out, it doesn't transfer the heat as well, and then of course that can destroy them. Let's check our input MOSFETs. Well, I can't find a schematic for this oddball machine. No surprises. And get your eyeballs on focus. Oh, that looks pretty good. Okay, and oh, power cable's going to pull it off the table. There are our input MOSFETs on the back of the DC-in jack, the charger jack, and we are set at 1 volt per division, which is way too low for doing this sort of test. Let me just change that. We are 10 volts per division. We have our 19 volt charger input attached. 19 volts. And as you can see, it comes down through the one side of those MOSFETs. Let's have a look. They appear to be in, well, they look like they're in parallel. That side has 19. We have a bunch of vias here and a bunch of vias here and here, so jumps through the board at some point. But if we have a look on this side as well, and we should have, what have we got? 19. So it is flowing through these. They must be in somewhat of an on state. There's the gate there. This is that one. So that's probably about 8 volts. It looks like on each gate. So where does it go next? Let's go looking for our standby voltages. Need to tie up that power cable so it doesn't keep pulling it off the board, off the table, pulling the board off the table. What do we got? So there's our input MOSFETs, and if we head on over this way, we come across an inductor. I don't know what that does yet. Remember, no schematic. That inductor. Right, reattach, and we're going to need to go down, let's say 2 volts per division, because we expect it to be lower. And on the end of this inductor we have nothing, not a sniff. So then if we head on over this way, we find another one. And what is this doing? Nothing on that one. Over here we've got some more, but they head on over to the CPU. So these ones are our CPU rail generators, and that one back there is doing something as well with the CPU, because you can see how the traces come down and underneath the processor there. This one sitting there on its own, maybe that's important. That is also not generating a voltage, and that's in between the CPU and the GPU. We have some more over the far side to the right of the processor, which is probably also some kind of processor rail, but just in case, yeah, nothing's happening there either. If we have a look here, this is our GPU, and these 3 are our GPU power supply. And then this one down underneath, we don't know what it does. So we'll check U, and we've got nothing there. And then the one directly below that, we've got nothing there. I would expect maybe one of these is memory. So if we have a look over here, you can see there's our RAM slot to the right with a card in it, and this looks like it's headed in that direction, so I'm going to say that that's probably our RAM voltage. That one up there is an unknown at this stage, and then we have, there's our battery connector, and then straight up from that we have another one. So if we probe on that one, possibly something going on there. So at 1 volt per division, it looks like about half a volt, give or take. So maybe it's trying to fire, but it can't for some reason. Let's have a look down beside the battery connector. I would say it's probably our charging MOSFET. That has pretty much nothing going on there. Sorry, inductor, our charging circuit. That'll be our charging MOSFET there. That'll be our charge controller IC there. Manages the battery without looking it all up, just based on position of things. And then there's our one with our half a volt on it, and if we head on up this way a bit further, we can see another one, which is a bit hard to tell what that feeds yet, and we've got nothing on that one. Just down to the left of everything we have our, what some people call our super I/O. This IC is what tells everything to turn on, takes the input from the power switch, and among many other things. And we have no schematic, so maybe is this our BIOS chip with the little yellow dot? Is that our EEPROM? See if we can get a number off that. I think that says BH1551. I'm just putting a little ISO on that and trying to catch the shadow. BH1551. Nope, that's not the number we want. It must be 25D05BT. 25D05BT. That kind of gives something. Giga device semiconductor. Okay. Possibly an I2C EEPROM. IC EEPROM. Serial EEPROM. Yep, it's a serial EEPROM. And possibly a GD25D05BT IG. Oh, there we go. There's a data sheet. I'm just being rude and not sharing my screen. So we have pin 8 is VCC. I am curious about that. So let's see what's on pin 8, because when you first plug these in, I think the Super I/O does read the BIOS and then waits in standby for things to happen. So that needs power on the EEPROM to work. So let's have a look at pin 8. What have we got there? Looks like our same half a volt, which is interesting. So from that, I would almost certainly say that it would share the same power rail as the Super I/O. And if I just quickly look at the data sheet, absolute maximum values, if I can find them. Power supply 2.7 to 3.6. So I would guarantee that this over here that's struggling to do more than half a volt. Wait, wrong one. Which one is it? This one down here. Here we go. This one here, which is trying to do half a volt, because it's the same voltage on pin 8, I would say this is our 3.3 volt regulator, and it is not coming up to 3.3. So perhaps we focus our attention there first. I don't know which one would be our 5 volt regulator, but I would almost just hazard a guess it's the one next to it. I don't think it would be this one up here. Maybe this is graphics memory power. Just looking at this and its position to here. So this capacitor here in this position. It's a big capacitor as well, so it's a fairly hefty power rail. So I'd almost say that that was actually for graphics memory. Almost. But yeah. Let's see if we can figure out why we don't have 3 volts firing up on here. Maybe that's the answer. Right, so this chip needs power in order to operate. So let's just see what is on it. And we have on the left side, I can't find a data sheet. I don't know what this thing is, but there's nothing happening on either of those 2 pins. I would imagine one is ground. And then that pin has nothing. That pin has nothing. Nothing. Nope. Nothing. Oh, point 2, 0.1. Nothing. May as well be nothing. And down the bottom here we've got that's maybe our feedback line that goes back to the other side. That's nothing. That's just our half volt. There's half volt on there. And nothing there. Nothing there. Nothing there. So I don't know if there's a pad underneath this that might be connected to something. There's definitely nothing on any of those other pins, which doesn't seem right to me. I would have thought maybe the 19 volts would come in this side, because this is such a large pad here and a couple of input caps would make sense. So let's see if we can figure out which side is ground. So we have sounds like ground. That also sounds like ground. 0.7, 0.8. 1.0, no, that's 0.7 or 8 as well. It's entirely possible we have a short on whatever this rail is here. If I just, okay, yep. So that doesn't go back to the BIOS IC power, but the inductor does. So I think we're on the right track. We're not getting enough of a feed in. I don't know where the power is leaking through to that coil, like unless there's a pad underneath. Unless there's a pad underneath that chip. We need to focus on this side of this chip, and wherever that goes, and find out why there seems to be a short on there. Maybe that's our 19 volts in, and it's not happening. If I look on the other side of the board, I can't see anything because it goes off into the middle of the board. And if I look at the other side of the caps to the other side of the board, I have the same thing. It disappears into the middle of the board. So that is no help to me at all. But maybe we can just use our meter and just check around and see if we can find it pop up somewhere else on the board that may help us out. Well, it took a while. I'm running all over the board trying to find out where the output to the MOSFETs comes in. So I was going here, and we can see that if we put our meter on the pin of the DC jack and go here, this is the side that it comes in on. So the left side is our output side. And then I was like, where does it go from there? And I was trying to find points all over the board using my rake, just a wire like all brushed up. So you can stick one meter lead in the end and just run it over the board until you hear a beep, and you can cover more connections at once. It doesn't need to be a bit better spread than that, but then I was about to give up, and I thought I'd just try one more spot that kind of looked interesting. Now with the board upside down, I've got a test point here that you can probe that same set of pads on the other side, because it doesn't really come through to this side at all. It's just that component missing in this test point. So with a probe on that test point, and then we come all the way up to here. Now if I zoom out a little bit, try and give you a bit of context. We have a block of rubber which just oh no, okay, so yeah, support. This is your battery connector, and then just down from that we have a diode. We have a few diodes in that area, and then when I probed from there to the diode, I got a connection. So that's where I'm at. Now I'm going to check whether that diode's okay, because maybe it's not. Maybe it goes other places as well, but I'm struggling to find any. So go diode mode there, and looks like anode left, cathode right. and we have a 0.6, so that's okay. So we are getting our 19 volt flow through there, although I wouldn't have thought that would be our main feed exactly. And then we have what looks like a 10 ohm resistor, 100, so 10 and then 0 zeros after that. Let's just see if that resistor is okay. And it looks like it is 10.6. So just because I'm here, I'm going to check those other diodes. That's okay. That's okay. So maybe it has to do with charging. Those diodes there may have to do with charging. There's another diode there. We might as well check that while I'm up this end. Don't know where it goes. And that looks like a Schottky diode is 0.19. So still at a bit of a dead end. These transistors are not melted. It's just a bit of the glue from the plastic cover that sits over the whole board. So we're still unknown as to why we have a short on that rail in particular. Possibly, well, the input to that rail. We can't find where that 19 volts goes after that MOSFET, and it's certainly not to all of those diodes that look like diodes. They look the same. Ah dear, it's never easy. What do we got here? No short on that lot. No short on that lot. That must be the. Then we got over here. We got 1.9 or 1 ohm there, which seems excessive. But that comes down to. Well, there we go. No, it doesn't. Thought it came down to these big ones here. I mean, looking around, nothing looks burnt, physically damaged that could be causing a short like that. But maybe because it's such a low short, we don't know what side ground is, but if we just jam some power onto it, because it's so low, it's not going to allow any reverse flow. So we're not going to have a problem if we get the polarity wrong. Yeah, I think we're running out of options because we don't have a schematic to tell us. It's present on this side, and I think it's present on this side up top. Let me see if I can focus. There we go. So it's present up here, which will be our input, I believe, which is then being switched through the controller to the inductor there for that rail. Is it present up here? No. Good. And then what other rails we got? Memory. So does that will be generated off of something else? Possibly 5. Maybe it drops 5. We're okay there. We're not okay there. So whatever this is, we're not okay. I guess it could be okay, we're not okay there. It's like the whole primary side is being pulled down by something. That does look discolored. Maybe that's a good starting point. But I would think a short like that would show itself pretty quick. See, that's a good looking MOSFET. Those are good looking MOSFETs, as are those. That one may have been discolored at one point. That certainly has appears to have a short across it, so we may need to check that one. And that one. Just going by the color of them, which looks a bit dark for you, just looking at that. The lettering stands out on those a little bit better than that one, and a whole lot better than that one. See those ones there, good bold lettering. That one seems to have got hot. Looks bad. That could very well be, in fact it is, I think, that's one of those packages that has pads underneath, so it's like 2 MOSFETs in one package, whereas these ones, well, they could be as well. Actually I think these all are, what's the number there, PGC GUC 2S05, GUC 2SO, or 2SOS15, yeah. Alright, they're all the same package. Running out of ideas. How about we just pull off the discolored ones, because they switch from ground to rail, and if they're blown internally they could short ground to rail and be our problem. So it still doesn't explain how our 19 volts gets from here down to the rest of it, but that's not our concern at the moment. We just need to find short, and we are going to pull stuff off the board in order to try and achieve that, because there's nothing else you can do when you've got no schematic information, etc. Do I want to blow the hot air that way? It is heading towards the charge connector. I think we'll be okay. Yeah, we'll get the board up to temperature by just keeping the nozzle at a reasonable distance. I'd say it's probably about 2 to 3 inches away, or yeah, 60 mils, 70, yeah. It warms up pretty quick at that distance. I've got it set on 380 Celsius. So I usually wait till the board feels quite hot near one side, so it's, you know, it's reasonable distance from the part you're trying to remove, so you know you've got good heat soaking into the board if the other side of the board is quite warm. And that means you spend less time close up on the device. Everyone making a note of where pin 1 is? Oh yeah, it's got a little triangle here, that's handy. And a dot. So we know where pin 1 is. Oh, I was wrong. I think. Oh no, it wasn't. Yeah, it's got a pad in the middle, separate pad in the middle. Okay. Do we still have our short? Across here? We do. So it wasn't that one. We could pop him back on, I guess. While it's nice and warm still. We'll keep working while it's warm. We'll have a look at the other one that caught our eye up top there. See, do we still have our short? Yes, we do. Okay. I really need a thermal camera. Anyone gonna donate me one? Well, I'm left with a few options. I suppose it could be, I bet this has got a short on it too. I bet this is our same rail. Wait, that one. There we go. Because you can see that feeds into this little regulator chip as well, the same way. So it's this entire rail. It's got to be our 19 volt feed. I'm left with at the moment no option but to pump voltage into it and see what gets hot. And I'm going to pick down here to stick it in. And for no particular reason, and I really don't know which one is ground. So without a data sheet, just thinking out loud, this is a switching regulator, so it is going to have a built-in MOSFET. So would we get a diode reading if these this is our input and this is our output? There'd be like maybe a diode reading across you know, between the two, like, you know, between the gate and the drain and the source of a normal MOSFET. You'd have maybe a reverse body diode. Sort of wondered, so let's have a look here and here in diode mode check. Now these two pins on the right are linked, and I get 0.32. And if I go from the coil, I'm just going to use the capacitor pads because I can't, you know, just to make it easy to, that connection there to the coil, 0.37. So there to there, 0.32. So there's some kind of diode junction in there, and of course we're getting the same on the other pin. Even though they're isolated, there's a short across here somewhere, so that is that's interesting. So we know that. So let's have a look at another similar switching regulator, and we've got this one that has a different layout but the same kind of thing. So here's our inductor that connects underneath, I think, possibly, yeah, to this pin here. Well, we've got these pins up here, so I've got 0.35 and the same on that side, because this capacitor here, must be our input that it's switching through to the inductor, and we've got a short across there as well. It's the same input as the other one. So I thought, oh, let's check this one up here. Same again, and I'll go coil to input, let's get a better connection there, 0.05 seems a bit low. It's jumping around. It could be my connection jumping around a bit. Okay, so what if we go to the pin beside it, 0.05 again, and if we reverse it, it's going to be probably the same. No, 0.03. So that's interesting. We get a different reading across this very similar layout, although slightly different number, IC package, which makes me wonder if the problem is this IC. Let's remove that IC and see if our problem further down the board goes away. Head back on over and make another measurement here. See if we're on the right track. Sadly, we're not. No. Boo. What is our diode reading with the package removed? Have we got something else funny going on in circuit? Same. Yeah, okay, so with the chip removed, we have the same low, oddly low diode reading. And how is that possible? When this coil is now isolated at one end, we're measuring through to somewhere else, which is somehow darting back to the input. Let's see what our resistance is across this then. What are we getting? 21 ohms. Well, that's probably, I don't know, would that be acceptable? I don't know. If you had 19 volts on here, let's hang on, get the other side. 22 ohms. Strange. Stranger and stranger. And I think, just thinking they're going to be joined, aren't they? Them and them are joined, and them are joined. It could be anyone. We're going to have to pull them all off. What a pain. Still beats just looking over the board and dumbfoundedness. Let's get that reseated. Well, I have moved all the caps off of their pads, shoved them over one pad so they're not connected anymore, and it keeps them in place so you don't lose them. And I've got that bunch there, and if you come over here, I've removed all of these MOSFETs, and the caps that tend to float around there have been pushed out the way. And if we come down the far side, there's another 4 MOSFETs gone, another couple of caps, and a melted sticker in the process. And then we come back over to our original position, starting position, where we found our half a volt, and we have all the MOSFETs taken off of the GPU power source. And oh, I just realized I didn't take the caps off, but I've got all the caps removed down here for the original supply we were trying to diagnose. Before I get too carried away, oh, it's already cooled down. If I have to, I'll take those other caps off, but now let's see what kind of resistance reading we have on our original problem. Still a short. It ain't good, sir. It ain't good. Whap, whap. I got to take that cap off. So I left that cap on. I got to take that one off. Still could be that. Could be that package. It may have 0.8 across from the input to the coil, but that doesn't mean it's not shorted internally. Could be that as well. Let's get rid of these caps and start to cry. Well, we'll have to take those caps off as well. We already took that fed off and it made no difference, so we just look at the caps, see where we get to. Make sure you don't drag the solder over with it to form a bridge and keep it connected. Yeah, I wonder if these caps are anything. I think they're just on the gates, they're not going to be an issue. We've got that one down there, which is... Can't remember if these ones down the bottom were on it. No, they were separate. So as I said, that must be formed off of perhaps the 5 volt rail, and the rest are derived off the 19 volt rail. Possibly. Do I let it cool down or do I just go in for the kill? Aha! It's gone! Ah, it was one of those other caps. Which one? Eeny, meeny, miny, mo. Do we go probably that one that looks a darker colour than all the rest of them? I like it when a plan comes to fruition. Let's let this board cool right down again, because we could have... I mean, she's pretty hot, I can't touch it. Right, she's cold. Let's crack on with it. Let's not get our hopes up. I really hope this is it. So, eeny, meeny, miny, mo. It's definitely not. Definitely not. Out of curiosity, which one is ground? It is the bottom one. Haha. Alright. Okay. That's what I thought it might be. Let's check door number 1. No. Door number 2. Aha, there it is. Rotten swine. Door number 3 is good. These are all good. Just make sure we don't have 2. We could have 2. What if we had 2 of them broken? Imagine that. Alright, it's that one. Let's have a closer look at that one. That does look a bit discoloured to me. And I'm just going to dab a bit of alcohol on it and give it a clean. Oh, look at that. In the right light, it is cracked. It is fractured. I don't know if you can see. No, you can't see that, what I can see, but as it's drying up, actually you can have a look. Let's get it wet again. Have a look right about here, right across here. There's actually a crack. You can kind of see as it's drying up. There it is. See that? Down the, yeah, you can see a crack. Yeah, it's fractured. Many places it's fractured. Wow. I have to remember to look closely at things next time. Save all of this desoldering. What? At least we found it. But what do you replace it with? Well, we think it's 19 volts, don't we? So, can we... I don't even know how it gets here, because if I measure the output of the input MOSFETs, it just doesn't get down here. So it must go through another MOSFET or something, some kind of switching that was loading it down, loading that switching down. Oh well. While that is off the circuit, let's just do a capacitance measure on a good one. And it says looks like 20 microfarad. 20 microfarad. We'll check that one. It's bound to be the same. Yep, 20 microfarad, and I'm going to say 19 volts. Now all we have to do is find one of those. Let's go about putting this thing all back together. Now that we have everything reattached, we need to make a couple of checks, because it was a lot of work we've done and we don't want to have created a problem having done that work. So we're going to go into continuity mode again, specifically with the beeper, and it's just a nice quick way to hear if you've got a problem. So what we're going to do is, there's 3 pads under this MOSFET, which is the same MOSFET used all around. We've got the one on the end for these pins, the one on this end for these pins, and then one in the middle that goes to the coil. And what we don't want to have happened is when we put this back down, I didn't redo the solder, I just plopped it back on what was originally there. But what we don't want to have happened is if the solder bridge has formed underneath. Now I did use some flux, and you could see it was floating on the flux, and if it's floating, then the flux is going to cause the solder to sort of pull onto the wherever there's exposed metal. So that should be all okay, but we need to be sure. So if we go from this pin, which these 3 are all connected together, so it doesn't really matter, to the coil. Now it is beeping, but it is 8 ohms, so that's acceptable for a GPU resistance. So what I'm looking for is anything that's like below an ohm, actually shorted. We also want to check to the gate pin, which is separate, so we would go from there to the gate pin, and there's nothing there. We want to go from there to the other side to make sure that it hasn't bridged through, although if it had somehow managed to jump from there to there, it's going to be touching the center pad, so we would have found that before. And then from the left side to the inductor, so there's no bridge from there to the center, and then the gate, of course, and there's nothing going on there. So everything looks good, and you want to just check all of them. And of course, after having put everything back on, you want to check that there's no longer shorts across our rail that we had the issue with, and that's still good. In case you're wondering why we want to check for shorts there, well, we've got 19 volts on one side of this MOSFET, and it's only passing through a small amount to create the rail. When I say a small amount, it's 19 volts, but very, very briefly, so that the average voltage becomes what we need for the GPU and CPU. But if it's shorted, we're going to get 19 volts just straight through and blow up our CPU.
Alright, I'm going to plug it in and let's now see if we have our rail returned. And I've got no heatsink attached, so let's hope that it doesn't want to turn on. Alright, where are we? There we go. So I'll probe on there and I will plug it in and hopefully there's no smoke. Well, it looks like my software has stopped again, so I don't know. Is it even running? Oh, might have forgot to hit record for part of that, but there's nothing to know. We had none of the other inductors up the top of the board have anything on it. We have this over on the one near where we had that sort of half a volt previously, and that's something that's starting up and then failing. So maybe we've got another short, whatever rail that is, something else going on there. So we're on that inductor there, which is the one above the initial one we were looking at. Nothing going on there. And we've got our almost 3 volts there, so we don't have enough voltage coming in for these regulators to do their job. It was shorted to ground and now it's just kinda meh. So I think something else has been damaged in the process, and now when it's trying to pull current through, because of the short, it's gone and damaged something that it goes through, and I need to find out where that is. And I'm just seeing if I can feel any warm spots on the board. Maybe some giveaways. Let's check around. Here's those diodes again, just out of curiosity. See what we've got on the side of there. So, okay, just over 2 volts there. Nothing there. So that was on the diode by the battery input. So we got a couple of volts there. If we go over to the one that we can see our 19 volts comes in on, we have off the charts there, so that's our 19 volts. And I've just killed, of course, because it didn't like to go off scale. We have 19 in there, 20 volts per division. We have same coming out, which is good. And that diode, and that's reverse, so that's fine. That's got bugger all on it. It's got not much on it either. We still don't know what they do. I swear it feels like this top of the board, there is some little bit of warmth being generated compared to the other side of the board. It's very minimal. Very minimal. It's going to be a bit hard to pinpoint where it might be coming from. Let's try using the face, because the face is nice and sensitive. Alright, I think I've found it, and it does make sense, and I should have thought of that earlier. So the only amount of warmth I can really find, if anything, is around what I believe the charging controller, which is that chip there, that MOSFET there, and I think that is our inductor that is used to charge the battery. On this side we have our 19 volts. On this side we have our not much volts. So either on the gate we have a similar amount of not much volts. It kind of matches the output here. So either the MOSFET's damaged or this IC's damaged. So let's take a look at the MOSFET, because what's going to happen is it's going to allow battery voltage to come into the system via, we got a battery connector there, so it looks like it comes in via this resistor as a current shunt, so it can measure how much power it's drawing off the battery, and then it goes to here, and then quite possibly, through the inductor, through the IC, and then back through this MOSFET to power the system. So yeah, so back through that MOSFET and then through here to power the system. Possibly it may go straight to the system after the inductor, or it may not go through the inductor, I don't know. But yeah, if system power goes through this MOSFET and through the charger, that could be our issue. Don't know. Maybe this is just idle switching of our charge system because there's no battery attached. I don't know. Let's check that MOSFET anyway. There's not a lot of obvious to me that I can check. So our gate source, what's that, 0.14, gate drain 0.6, drain source 0.5, CHLO121 or B12N03 I think would be the number we want. So it looks like our body diode's okay at 0.5. What if I go backwards on that? Yeah, that's our body diode. And that's in that direction, which allows, I presume, would then allow battery voltage to go back through to the system. Well, fancy that. If I go from the cap that we had our short on, the rail that we had our short on, let's make this better for you. So if I go from, this is the positive side of the rail that we had our short on, to the output of the MOSFET here, there we go, it's directly connected. So this should be our charger in and then out to the system. When that MOSFET's turned on, we're running on charger. When that MOSFET's turned off, we're running on battery. At the moment it's trying to turn on and failing. Does it think there's a overcurrent situation because it's metering it off the input resistor? Let's check to ground. We don't appear to have any issues to ground. That's megohms. Out of curiosity, we'll go here, and our main rail is still K ohms. So that's fine. I wonder if our little current sense resistor is damaged, and that says R012 would, what's that, 0.12? It's measuring 0.5, so I'm going to say it's probably 0.12, and the R0066 to the battery is, yeah, pretty low. So that's not a high resistance, that's not our issue. So maybe that MOSFET is just bad. Maybe it's not turning on thoroughly. Do I have another MOSFET that I can steal off here just to test it with, or maybe just go find another one? What rail don't we want? These are all different anyway. Let's let's look at the data sheet and check what type it is, because those are all the same. But I think that could be the issue. The cap shorted and damaged that MOSFET. I can't find a data sheet, but I'm pretty sure it's N channel, so I have got something similar-ish that will do the job. I don't do enough of these to remember what parts I've ordered, but I think I've got some brand new stock, so let's just see what happens. Whoops, no, I don't have new stock. That was completely the wrong package. But I do have an old motherboard with, hopefully, that there is 30 volts and sort of 80 odd amps. That's like way overkill. But here's our old one. Let's just poke it with the meter, see what happens. If we have anything, I flip it over so I can push it against something. Gate related. No, not really. Ooh. That says short, so that's that's normal. That's internally joined. Those three. Gate to there is nothing. Gate to there. Nothing. That is now turned on, so we've got a short, and we'll bridge out the gate, and that is now body diode, and the other way is okay. I don't think that's bad after all. It turned on and it doesn't show an issue. Gates to the pins next door. Source. I knew it was source. Alright. Let's pop it back on. It's starting to look horribly like maybe the charging IC got damaged in the process. While we're thinking about potential issues with capacitors, maybe we check that one on the gate. It's probably not an issue, but you never know. Probably get some more solder on the other side of that actually. Haven't yet found a data sheet, but this is the thing, and it's got 3 large pads underneath it, so unknown where they go to, and the closest thing to a data sheet, well, I've got this reference schematic, so this should give us an idea of how it's supposed to be hooked up. And if we have a look, the pins, they are numbered kind of. pins along the top row, we've got, looks like 25, 24, 23, 22, 21, and possibly 6 and 43. So what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to show you what I'm counting. Okay, so we've got 10 per side, and we're looking for 20, 1, 2, 3, 4, 5. So they go to our inductor. On here it shows they go to what's called VSYS. Now VBAT should be 20, 17 to 20. So if we have a look on here, 20, 19, 18, 17, this should be VBAT. Just zoom out there. Okay, so 17 to 20 on this corner. So this is VBAT trace. It's on this side of the inductor. So that's correct, because you can see it comes from the battery through our sense resistor and into here. So that's VBAT. We have a switching control to the coil, which is pins 27, 33 and 34. So 27, 33 and 34, so that's 10, 28, 30, 29, 28, 27, 31, 32, 33, 34. Okay, so if we zoom in there, oh yeah, so that goes to the coil. So we've got 31, 2, 3 and 4, those two there. They are probably linked underneath to 27 and 26, did I say it was? No, 27 and 33 and 34. So 27 being that one, and 33 and 34 up here. So that's alright. So that's to the coil, which is fed from VBAT, and we can see that there. So there's VBAT through the coil, through our sense resistor, through the coil to here. And the other thing we're interested in is this MOSFET up here. So AD plus is going to be our adapter in, our 19 volts. So that comes through the sense resistor that we looked at, through the sense resistor into the MOSFET, and the MOSFET goes into pins 13 to 16. There we go. There's our sense resistor into the MOSFET, and that should be pins 13, so 10, 11, 12, 13, 14, 15, 16. So this schematic is right for that chip, and that's how it works. So we are on the right track. We need that chip to turn on the gate to pass all the 19 volts into itself. Now, once it has a V adapter in, I'm picking internally it's going to pass it back through to VSYS, and it's also going to switch it across the inductor for charger. And of course, when the charger is not plugged in, we'll probably get flow from the battery back through the chip and out to VSYS. So it's going to have a big internal MOSFET or couple, and it appears to have serial data. So that's probably for communication to the battery and the system, probably for battery stats. What else has it got? There's some grounds. Is there some kind of enable? Is that a feedback FBV? We've got I out. Is that current out? So it's monitoring the current through the sense resistors and maybe spits it out that line for the system to determine what the current draw is. Well, we know we don't have any low resistances there, and that's our system line. Pins 21 to 25. They go out to our system. 1, 2, 3, 4, 5. And they go out to our system underneath the inductor. Okay, so let's just take a measurement there. So those go to, yes. So yeah, those pins there, let's say they go to system, definitely go to system, are on my capacitor at the top, which was our initial fault line. So I don't think, no, we've done ground checks against that and that and that and that and that and that and that. What about just do a diode mode? So it's got to go from the MOSFET out to the system, which right now appears to be shorted. It must be shorted through the chip. So our output of the MOSFET there is going, give you a better reference. The output of the MOSFET there is going to here. It appears to be a dead short, which is probably not ideal. It's not ideal. Well, it's 3 ohms, but I mean really going through the chip, no, that shouldn't be 3 ohms. I think because, just have a look at that other picture I had of the underside. I wonder which one pin 1 is. Hopefully it's flipped. Pin 1 would be the chamfer, which would mean it's sitting like that. Oh, hang on. I think I made a mistake when I was saying about the battery before. So the battery, I just noticed, you got your battery in, and then it comes up here to VBAT. So when it's running off the battery, it's not going back through the inductor at all. It just goes straight up to VBAT, which would be passed through to VSys. I wonder if those two are shorted as well. Let's check. Battery comes in here, and unless this chip's enabled, it will go through the internal diode and out to the system. When it's charging, it will break that connection and the battery will be fed from the inductor voltage. I'm at a loss. I think I need to replace that chip because the power does go through that, and when that cap's shorted, it would have taken a surge through that chip, which probably has damaged it. Okay, look, I plugged the battery in, and I can tell you that we now have our 3 volts. This is our 3 volt line. Oh, with the first one we were looking at, we have 3 volts on there, and we have 5 volts on here with the battery connected. So I think we need to order that chip. I think that will do it. It's just not able to pass through the adapter power. Oh dear. Well, I for whatever reason, I got the chip. I didn't record the installation of the chip. It's most unfortunate, but it was just taking a chip off and putting a chip on, nothing special, and I can tell you that fixed the problem. It was definitely that capacitor shorted, and with 19 volts behind that short, it would have been a huge current surge through that body diode in that chip, and yeah, just shorted it straight out inside the chip. So thanks for coming along and following my thought process there. And see, you don't need a schematic to fix anything. You can just persevere and nut out the circuit, and with whatever, if you don't have data sheets, whatever info you can scrape together, you can figure out how the system works, and yeah, and you can be successful. So yeah, sorry I didn't give you a fan spin, but she's all good, customer's happy, and we live and learn. Catch you next time.